Cloud storage protocols provide an object interface. So what is an object interface, and what is the difference between that and a file system interface? An object interface provides named objects and read and write like operations, which may be considered very similar to naming a file and reading and writing it. But when we examine the details, we discover that they're very different. In particular, when we talk about a file system, we expect semantics such as the ability to have a hierarchical namespace, folders or directories encapsulating other folders and directories encapsulating files and yet more folders and directories. Some cloud storage protocols provide for that sort of hierarchical namespace, but some do not. When we talk about writing objects, most cloud storage protocols require objects to be written in their entirety. This is very different from a file system interface. Consider a simple example of an application writing a log file. Every second or so, it generates a few hundred additional bytes to append to the file. If we wanted to have a log object and continuously update it, we would have to keep reading the object in, or caching it, and then generating a new object with those few hundred bytes appended and write it out. Further, object storage protocols typically operate using a principle called eventual consistency. They use clustered storage, but in such a way that not every node in the cluster is fully synchronized with every other node at all times. That allows them to provide a high degree of performance and a high degree of availability, but at the sacrifice of that kind of consistency. Now, if you have a distributed file system, when one client writes a file and another client reads the file, we expect that after the first client has completed its write, the second client sees the effect of that write. Cloud storage protocols provide their performance and availability by sacrificing that consistency, so that second file system client, as a cloud client, would not be guaranteed to see the updates provided by the first client. Avere's cloud file system technology layers file system semantics, including consistency, on top of existing cloud storage buckets, allowing our users to take advantage of the availability and cost of cloud while getting the performance, consistency, and advantages of a distributed file system.